Hello everyone, this is Manoj Yadav and you are watching Mechanotherapy. So guys, today we are going to discuss beam. So first of all, you must know what actually a beam is. We can define a beam as a structural member which is used in building work. Okay, so it's a structural member which is supported at some points and which bears the load. So ultimately the aim of beam is to bear the load. You can see in the diagram, this is a beam and it is supported at these ends. This is one end and this is second end, and the use of beam is to bear the load. Whatever load acts on the beam, that load is bared by this beam. So this is beam. Now before going to the types of beams, we must know what are the various types of supports. So there are total 4 types of support. First one is simple support. Simple support, which is represented by a simple triangle. This is the representation of simple support. Now whenever we draw the free body diagram of simple support, we take one vertical reaction. Now second support is roller support. Roller support. The representation of roller support is like this, or sometimes it is also represented in this way, or sometimes like this. So these are the representations of roller support. Now in roller support, when we draw the free body diagram, we take only one vertical reaction. So in simple support we take one vertical reaction, and in roller support also we take one vertical reaction. Now the third one is hinge support, or which is also known as pin support. Hinge support or pin support. It is represented by a triangle with hatching, or in this way, or like a pin joint. So whenever we draw the free body diagram of a hinge support, we have to take one vertical reaction and one horizontal reaction. So we take 2 reactions in case of hinge support, one vertical reaction and one horizontal reaction. Now the third and last support is fixed support. This one is the fixed support. Suppose this is a beam and we fix one end. So this is the representation of fixed support. Now whenever we draw the free body diagram of a fixed support, we have to take one vertical reaction, one horizontal reaction and one movement. RA, suppose point is A, so we take RAB, that is our reaction at A, vertical, horizontal reaction at A, RAH, and movement MA. So guys, these are various types of support: simple support, roller support, hinge support and fixed support. Now you have to learn that which support is represented by which diagram, and whenever we draw the free body diagram of various supports, what reaction we will have to take. All these you must keep in mind. So now we will see the various types of loads. We have learned that these 4 types are the types of supports. Now similarly, the loads may also be different types. We have 3 types of loads. First one is point load. Point load. Suppose this is a beam. These are the supports. Supports may be different. It may be roller at one end and simple at other end, and this is the point load W. So a point load can be defined as a load which acts at a particular point of beam. Okay. So whenever load acts at a particular point of beam, then this type of load is known as point load. Now second one is UDL, that is uniformly distributed load. Uniformly distributed load is represented in the form of a spring, or it is represented in form of a rectangle with arrows downward. Now suppose the intensity of load is W kilonewton per meter. Okay, so in case of point load, total load is given, but in case of UDL, the load intensity is given. So for drawing the free body diagram of uniformly distributed load, we will have to convert this load into point load first. So in this case, if the length is L, then total load is calculated as intensity multiplied by length. Okay, so in this case, total load equal to intensity multiplied by length, and when we will draw the free body diagram of this load, this total load will act at half of the length. So we can draw the free body diagram of this load as this. Total load is W into L, and it will act at half of this time. WL is the total load, and it will act at L by 2 from this end and L by 2 from this end. So this is all about uniformly distributed load. If a load is distributed uniformly over entire length of beam, then this type of load is called uniformly distributed load, and in this case total load is given by intensity multiplied by length, while it acts at half of the length. Now the third one is uniformly varying load, or UVL. This is a very important type of load, UVL, or uniformly varying load. You can see in this diagram that with increase in length, the load is varying uniformly. Up to this length, load was up to this height, up to this length, load is up to this height, and up to this length, the load intensity is this much. So suppose load intensity is W kilonewton per meter and length is L. Now, while drawing the free body diagram of uniformly varying load, we will have to convert this into point load first. So in this case, total load is given by 1 by 2 load intensity multiplied by length. This is total load in case of UVL. Now this load acts at 2/3 of total length from the vertex. You can see here we are having the vertex, so the total load will act at 2/3 of length from the vertex. Now we are drawing the free body diagram of this uniformly varying load. Here the total load is 1 by 2 WL, and it will act at 2L by 3 from vertex and L by 3 from the base. So in this way you can draw the free body diagram of uniformly varying load. So guys, this is all about various types of supports and various types of loads. Now in our next chapter we will study about the various types of beams and how to calculate the reactions in case of beams. Thank you everyone.